Latitude and longitude lines represent geographic coordinates used to specify locations on the Earth's surface. They represent angular measurements that help define a precise point's position on the planet. But one of them, latitude, gives us a good perception of climatic zones. How does it exactly do this, though? Let's find out. The Earth is made up of distinct latitude lines that start at the 0-degree line, the equator, and go north and south to 90 degrees. At 90 degrees north, the North Pole is represented there, while 90 degrees south, the South Pole is represented there. The further north or south you go from the equator, the more progressively colder it gets. Why does this happen? And are there other factors that affect climatic zones other than their latitude? In this week's episode, we're going to focus on how latitudinal lines affect seasons and daily sunshine hours. Then we'll review certain oddities of climatic latitudes and why these peculiarities are present. Before we begin, make sure you subscribe to my channel, Our World, Our Planet, Our Home, if you enjoy learning more about geography and earth science. Let's begin. Besides the equator, there are 4 other important latitude lines associated with seasonal variations on climatic zones. The Tropic of Cancer at 23.5 degrees north, the Tropic of Capricorn at 23.5 degrees south, the Arctic Circle is 66.5 degrees north, and the Antarctic Circle is 66.5 degrees south. Each of the main latitude lines is correlated to seasonal variations. The Earth is on a 23.5 degree axial tilt. This axial tilt is responsible for the changing seasons of the Earth, as different parts of the planet receive varying amounts of sunlight throughout the year due to the tilt on the axis. Let's start with the equator, 0 degrees latitude. At this line, the sun is directly overhead on what's called the equinox. The equinox occurs twice a year, on or around March 20th and September 22nd. On those 2 days, respectively, they are the first days of spring and autumn for the Northern Hemisphere, and the first days of autumn and spring for the Southern Hemisphere. Globally on those 2 days, every area of the Earth has around 12 hours of sunlight a day. The solstices are associated with the sun being directly over the Tropic of Cancer and the Tropic of Capricorn on or around June 21st and December 21st correspondingly, 2 lines of which are 23.5 degrees north and 23.5 degrees south. When the sun is over the Tropic of Cancer on June 21st, it's the first day of summer for the Northern Hemisphere and the first day of winter for the Southern Hemisphere, while when the sun is over the Tropic of Capricorn on December 21st, it's the first day of winter for the Northern Hemisphere and the first day of summer for the Southern Hemisphere. This also means that on June 21st, the Northern Hemisphere sees their longest days and the Southern Hemisphere sees the shortest days, while it's the opposite on December 21st. One unique trait about the solstices is sunshine hours in the far northern and southern latitudes, and this is where the other 2 lines, the Arctic Circle and the Antarctic Circle, come into play. The Earth is a spherical shape, and this allows for there to be different daylight hours at different latitudes. In the equatorial regions, sunlight throughout the year is overhead, and therefore daylight hours are uniform, at around 12 hours each day. The further north and south you get from the equator, the more daylight variations there are. Then above the Arctic Circle and below the Antarctic Circle, at 66.5 degrees north and 66.5 degrees south, the extremes become very pronounced. Because of the horizontal angle of the sun in the Earth's spherical shape, the summer months see very long sunshine hours, with the North Pole at 90 degrees north seeing 24 hours a day of sunlight from March to September, and the South Pole at 90 degrees south seeing 24 hours a day of sunlight from September to March. In the winter, the reverse happens, as areas above and below the Arctic and Antarctic Circle respectively see no sunlight for a period, with the North Pole remaining dark from September to March and the South Pole remaining dark from March to September. Long daylight hours are known as the midnight sun, while long dark hours are known as polar nights. In terms of human geography, far north and south latitudes have societal effects. Long daylight hours during the summer may cause insomnia, as circadian rhythms can be affected. Long dark nights can cause seasonal affective disorder, in which a person becomes depressed because of the lack of sunlight. Now that we have covered how seasonal variation works, let's look at latitudinal similarities and differences associated with climate. The major similarities are greatly connected to the hours of daylight and the angle of sunlight each latitude receives. Singapore is a city-state located at 1 degree north latitude, pretty much equatorial. Throughout the whole year, the sun angle is between 68 degrees to 90 degrees, which allows the city-state to receive a lot of vertical heating. But because of its latitude, every day of the year sees little more than 12 hours of sunlight a day. Next, Jacksonville, Florida and Shanghai, China, both around 30 degrees north latitude, see similar sun angles. Throughout the year, the sun angle for both cities is between 36 degrees and 83 degrees, and during the winter solstice, both cities see a little more than 10 hours of daylight, while during the summer solstice, they both see around 14 hours of daylight. Heading to 50 degrees north, both London, England, and Winnipeg, Canada are around the same latitude. Sun angles throughout the year range from 15 degrees to 62 degrees, and daylight hours on the shortest day is less than 8 hours, while on the longest day it's close to 17 hours. Finally, at 70 degrees north, where communities such as Tromsø, Norway is, the variations are extreme. Since it's above the Arctic Circle, Tromsø sees no daylight from November 27th to January 15th, but from May 18th to July 24th, it sees 24 hours a day of sunlight. As you can see, comparable latitudes show similar sun angles in daylight hours. But do similar latitudes see alike climatic conditions? Not necessarily. Another climatic factor is geographic positioning of a location. If a region is geographically located on the westward side of a landmass with the prevailing winds coming from a water body, such as a large ocean or sea, that area will see more moderate temperatures year-round. But if a region is located in the continental interior or on the eastern side of a large continental landmass where prevailing winds are from the land, these areas will see more extreme temperatures throughout the year. This leads to latitudinal oddities. Toronto, Canada, and Nice, France are both located at 43 degrees north latitude, but have considerably different climates. The prevailing winds over Toronto are from the continent, while Nice is from the ocean. Therefore, the median temperature in January is 25.3 degrees, while in Nice it's 49.1 degrees. In July, Toronto's median temperature is 72 degrees, and Nice's is 75 degrees, nearly equal. Before, we compared the sun angles and daylight hours of London, England, and Winnipeg, Canada, two cities of comparable latitudes at 50 degrees north. But the climatic conditions between the two cities are very different. Continental Winnipeg's January median temperature is 2.5 degrees, and oceanic London's median temperature is 42.1 degrees, 40 degrees warmer. In July, Winnipeg's median temperature is 67.5 degrees, while London is 66.2 degrees, a degree cooler. This goes to show you that the ocean is a great moderator and the continent is not. Overall, places of the same latitude may have similar sunshine hours and sun angles, but because of other geographical factors such as ocean influences, certain areas are greatly moderated compared to continental counterparts. Thank you again for watching this week's episode. If you would like to leave a comment, please do so in the comment section below. Be sure to like this video and subscribe to my channel, Our World, Our Planet, Our Home, if you enjoy learning about geography and earth science. Until next time!